Now that we've covered what the real numbers are and how we can use the number line to visualize real numbers, we're going to talk about operating with real numbers. And most of this next unit is going to be about how you operate with real numbers. I'm going to put a star next to this because being able to add real numbers is one of the biggest issues that students have. As soon as they see negatives in there and they have to operate with the negatives, it just becomes a huge issue. And it's not just students, it's really everyone. Errors with your sign numbers are some of the most common errors in math. So I'm going to demonstrate how you use the real number line to add. And there's a lot of different analogies that you can use, but I'm going to stick with the number line, and then we'll look at a couple of word problem applications that employ the same concept, because sometimes what can help students is finding some non-math thing that helps them visualize what's happening with the numbers. So let's take, for example, -2 plus 3. Okay, so we want to take -2 and we want to add 3. Now, here's the general idea. Negative means move left on the number line, okay, because that's where the negative numbers are. We might call that the negative direction. So I've got my number line here, okay, and you have the positive direction, and then you have your negative direction. So when you have a negative, you're going to be moving in this direction. Even if you're starting here, it tells you which direction you're going. And then a positive means move right. Okay? So we would move in the positive direction. So we're going to start at 0. Okay? And we start with -2. So I go 1, 2. Which locates me here, and then plus 3. So starting from the -2, I'm going to add 3. So 1, 2, 3, and you'll see that I end up at the +1. So -2 plus 3 is equal to +1. And common mistakes would be for students to say, oh, that's equal to 5, or that's -5, and just not really visualize it correctly. So negative, you go left, positive, you go right. Now, notice what happens. I'm going to go ahead and erase that. If you change the order. So what if we had 3 plus -2? Like, how would that change the problem? Or would it change the problem? So we would start at 0, and we would go to the right 3. So 1, 2, 3. 1, 2, 3. And that puts us at the 3. And now we're going to add a -2, which of course the negative means we go to the left. So we would start here and go 1, 2 back. And you'll notice that we are still at the 1. So 3 plus -2 is equal to 1. Now that's something called a commutative property, which means that you can add in any order. Just make sure that you move the negative sign when you switch the order of the numbers. I'll do a couple more, but hopefully you get the idea. We'll do -5 plus -2. Okay, so this is adding two negative numbers. And we'll do a couple over in the positive direction, but you probably get the feeling like we're not going to need those. Probably not. Okay, so starting at 0, I go left 5. So 1, 2, 3, 4, 5. Oh, I wasn't using purple there. And now I'm going to add -2, which means I'm going to keep going to the left. So it actually becomes more negative. I'm going to go 2 more, and that lands me at -7. Let's see. We're going to add, let's do this one. This looks like a fun one. Okay, so we're going to do 5 plus -10 plus 3. All right, so let's sketch our number line. And we have 0, 1, 2, 3, 6, and we'll go in the negative direction, like so. And we'll start at 0, and we're going to start in the positive direction. So we're going to go 5 in the positive direction. So 1, 2, 3, 4, 5. That probably doesn't surprise anybody. And now we're going to turn around and go 10 in the negative direction. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which brings us down here to the negative 5. And then plus 3 means we're going to go 3 in the positive direction, which is going to be 1, 2, 3, which lands us at the negative 2. Okay, so that's a really, really reliable way of adding and subtracting signed numbers. Now you might be thinking, oh, well, could we do a couple other things there? So you might think this, well, could you add 5 plus 3 together and get 8 and then add the 8 and the negative 10? Yes, you could. So if that was an idea that you had, yes, that would work. I really like the number line. I think it makes it very visual. And a lot of times we will talk about different kinds of rules for adding. Like if they're both negative, then you just add them together and you keep the sign. Like if they have the same sign, you add them together and keep the sign. If they're of opposite signs, you subtract them and keep the sign of the one with the larger absolute value. There's like a couple of rules that you can use, but I'm more of like find a process, find a concept that works, and the rules kind of take care of themselves. Like for instance, if we were to look at, say, negative 4 plus negative 5, okay, and you look at that on the number line, you would go negative 4, 1, 2, 3, 4 to the left, and then you're going to go 5 more, 1, 2, 3, 4, 5, which would bring you down to the negative 9. So it's really like just adding the 4 and the 9 together, or 4 and the 5 together, and you just keep the answer negative. But what I kind of think is if you use the number line enough and you take enough time to practice with it, you're just going to figure out the rules. You're just going to figure them out. So I'm not about like extra rules. All right. So there are a couple properties that are important though. So let's do a few properties that are pretty crucial. The first one I already mentioned, and that's this property. A plus B is equal to B plus A. We looked at that over here when we had negative 2 plus 3 and 3 plus negative 2, that it didn't matter which order you wrote them in, you could still get the same answer. That is commutative, okay? That is, let me write that out. Commutative property, not commutative, like no N in there, it's commutative. So that's what that property is. And it's important because not everything is commutative. You do have operations where you can't just switch the order, like adding is one of them, multiplication is another one. Another one that's really important is this. This is actually really, really foundational. And it seems pretty obvious. This is sometimes called the identity property. Okay, I don't think you probably need to know that word for anything, but it's sometimes called the identity property, and that's the idea that adding 0 doesn't change the value. That idea is so important for solving equations, because when we do our operations out, the reason why things cancel is because they come out to a 0 or sometimes a 1. That's for a future lesson. And then here's the last property that we really want to know. If you add a number with its opposite, you will get 0. So a number plus its opposite is 0. Let's take a moment and just kind of visualize that on the number line. Okay, so let's do like 3 plus negative 3. So what would that mean? We'd start at the 0, and because the 3 is positive, we would go 3 to the right. And then we're going to add to that negative 3, which of course the negative means we go 3 to the left, and we end up back at the 0. And that would work no matter which order you went in. You would go left and then you go right, and you're just basically going to end up right back at the 0. Again, this property here, like the one above it, this one is sometimes called the inverse property, because those are called additive inverses. But these two properties down here become absolutely essential for driving the process of solving equations in algebra. And so if they seem really obvious, that's awesome. Just kind of hang on to how obvious they are. Okay. And so, yeah, like, because we'll use it later. Let's take a look at a couple of examples that might bring this into a different context. So one of the illustrations that I use a lot in math when it comes to adding signed numbers is I use football, because a lot of times we're doing this in the fall and football season is taking off. I'm not a huge football fan, but I know enough about like gaining and losing yards. So here's an example. I'll take a moment and put it on the screen here. Okay, so because my handwriting is kind of terrible on this, your high school football team loses 4 yards on the first play and gains 12 yards on the second play. What is their net gain? And I do want to address this word right here. When you see net gain, that means overall. Okay, that is another way of saying what is their overall gain, or when all of the plays are done, look, where are they relative to where they started? So you can picture this on a number line. If you're on a football field, you would it would be like from wherever they're starting. So it might not necessarily be at the 0, but it won't change the answer to the question. So they lose 4 yards. So you can think of losing as moving to the left. So we go 1, 2, 3, 4. Okay, so -4 means they've lost 4 yards. Then they gain 12 yards. So starting from where they've lost yards, now they're going to go 12 in the positive direction, so they're gaining. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where does that put them? We need to count 1, 2, 3, 4, 5, 6, 7, 8. So they have an 8-yard gain overall. So football helps a lot of students conceptualize adding signed numbers. Some other things that use the same concept is atoms and atom ions. So this is this may or may not make sense to you. Based off of how much physical science or chemistry you've had, but in an atom, you have a nucleus that has neutrons and protons, and then you have these orbits with these electrons, and sometimes people put the little minus sign next to the electrons. So a proton has positive charge and an electron has negative charge. So if you haven't had physical science or chemistry yet, this is just a preview of amazing things to come. And an ion is when an atom has an overall charge. So in a normal atom, you would have the same number of protons as you have electrons, so they would balance out. So you might have 2 protons, then you have 2 electrons that go with it, and they balance out. But suppose you had an atom that had 10 electrons and 8 protons. So it has gotten electrons from somewhere else. And that is a question for a chemistry class. Where would it get these extra electrons, and what does that mean? But what that would mean here is that you've got 10 negative charges, so you would go 10 to the left, and then 8 positive, so you would go 8 backwards, and on your number line, that would put you at -2. And so we would say that this had a charge of -2. That's probably not it's been a long time since I've had chemistry. But it's the same concept. So you're taking the concept of signed numbers, integers, and now we're applying it into a science class. Another really common application is with money. And so by the time you're taking algebra, you probably have the idea that you can accumulate money in a bank account, but you can also go into this wonderful thing called debt. And debt is when you owe people money. So there's definitely a thing called negative money, and it's bad. Okay, or it means outflow. Spending money, and if you go below 0, you have a problem. But you can also think in terms of money earned is positive and money spent is negative. So I'm going to put another problem up here for you to take a look at just so we can get some more context. So what this one says is a company shows a profit of $13,142 in January, a loss of $6,783 in February, and a profit of $2,589 in March. What is their overall profit? And so you've got positive numbers. Well, here's the vocab word. Profit is a gain of money. Okay, and a loss, hopefully that's obvious. A loss is a loss. Profit means a gain. And always be aware of that in a word problem. If the issue isn't the math, the issue is a vocabulary word, and always ask or Google it or something if you're not sure what the word in the problem means, because you can't really answer the question if you don't know what it means. So what this would look like as a problem is you'd have positive 13,142 in January. Then you'd add to that negative 6,783 in February, followed by a positive 2,589 in March. And you can do that on a calculator. I'm going to take a moment and plug it into my calculator. So 13,142 plus negative 6,783 plus positive. You don't really have to say plus positive. I have a lot of students that say plus positive, but that is not necessary. And we end up with a net profit or overall. Okay, so that's the word from the last slide there, of $8,948. So try to keep in mind not just the signed numbers, but also some of the applications, the areas where you would see signed numbers happening. So as is usual, I'm going to put some practice problems onto the next slide. I might put a word problem up there as well, and then you would pause the video, give yourself a chance to work them out, and then we'll go over them. Okay, so what we have here are 8 problems. Negative 7 plus 11, 3 plus negative 4, negative 2 plus negative 8, negative 4 plus 5, negative 5 plus 4, negative 5 plus 8 plus negative 2, 10 plus negative 17 plus 1, and then I'll read this in case my handwriting is horrible. A company had a profit of $3,412 in April, a profit of $5,784 in May, and a loss of $9,013 in June. Did the company have a net profit or loss? So go ahead, pause the video, work these problems out, and then unpause it and check your answers. Okay, so for these problems, I'm just going to give the answers for the first 5, and then I'll model the number line for the last 2 just because those are a little bit harder. So for the first one, you should have gotten an answer of 4. For the second one, it should be negative 1. For the third, it should be negative 10. For the fourth, should be 1. For the fifth should be negative 1. And this pair right here is just worth observing, that when you flipped the signs on them, so like the 4 was negative, the 5 was positive versus the 5 negative, 4 positive, that it flipped the sign on the answer. That's just one of those patterns that's worth making a mental note of. All right, for the next one, we've got 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so for this one, we start at 0, we go left 5, then we're going to go right 8, okay, and then left 2, and you should have landed at the positive 1. Okay, and then for this last one here, I'm just going to model this out maybe in a faster way. We're going to go to the right 10. Then we're going to back up 17. So we're going to go back 10, and then 7 more, which is going to put us at -7. And then we're going to go forward 1, which is going to put us at -6. Okay, so hopefully those went really well. And ultimately, the end game is to not need a number line. So if you find that you can do it without a number line, that you can picture the numbers in your head and you can kind of slide back and forth without needing it, that's totally fine. Most of your math teachers, we do not make number lines for doing problems like this. But if you are finding it difficult, or you find that you're making a mistake, or the problems become a little bit more complicated, go back to the number line. It's one of the tools that you have to help you picture it. And it's okay not to use it if you don't need it. The word problem, we had a company had a profit. So remember that profit is positive. So the 3,412 is positive in April. The profit in May was 5,784. And so that was also positive. But in June, they have a loss. And so a loss means that we're going to be adding in a negative in there. And so that would be a negative. So the first two were positive, and the second one, and the last one was negative. So probably you want to grab a calculator for this. And I ended up with $183. Now, remember what the question is being asked. So if it's like one of those open response kind of things, and you answer $183, you're probably only going to get partial credit. Not because you don't know what you're doing, but because you didn't answer the question. The question that was asked was, did the company have a net profit or loss? And in this case, it was a net profit. And so you want to make sure that you actually answer the question, because the answer to the question was not the $183. The answer to the question was profit, which might be evident from the $183, but you always want to make sure that you're answering the question that's being asked. So this is a really, really critical and important lesson for moving on in algebra. And as I mentioned, I think in the last lesson, if you need more practice, seek out more practice. There's a lot of great websites and videos out there where you can just do a lot of adding signed numbers. So make sure that this is one of those skills that you feel very confident with.